This video will be debriefing the characteristics of vertex form task. Now, before we get started on what our going through our debrief, I would like to answer a few questions to define these following math terms. All right, so now we're going to define them together here. So we'll start with a maximum. Now we got to think back to before fall break, we talked about key features of graphs, but a maximum is the highest point on a function. Now, if the maximum is the highest point on a function, that would mean that the minimum is the lowest point on a function. All right. Now, vertex. We've not talked too much about the vertex so far. However, we have seen this in a number of our graphs. Okay. So our vertex, we're going to describe it as the point where a parabola turns. Okay. Now, turns is a little bit vague. And I'm being very specific here by just saying parabola. Vertices happen in a number of functions, but for now we're just going to talk about parabolas. Okay, so here would be a vertex that is a minimum, and then here's another vertex, a maximum. All right, now in your task, you were given the task of identifying the vertex of each parabola and stating whether it's a minimum or a maximum. All right, so let's go ahead and fill out our chart. Hopefully yours looks something like it. So, slow this down a little bit. There we go. So, for A, we have the vertex at 0, 0, and that is going to be a minimum. All right. Now on B, our vertex is at this point right here, which is 3, 0. All right, and that is a maximum. And C, here's our vertex here. That's where our parabola is going to turn. It's at -2 in the x direction and 1 in the y direction. So -2, 1. And that is also a maximum. All right, now let's go down to graph D. So in D, here's our vertex. That's where our parabola is turning. -1, -3. The vertex is -1, -3. And then we're looking at a minimum. Let's look at graph E. So we go over 2, up 1. 2 to the right and up 1. And that was a minimum. All right, now our last graph, we've got graph F here, that point all the way up there, 0 to the left or right, and then up 4. So 0, 4. And that is a maximum. All right, hopefully your chart looks something like that, with finding our minimum and maximum. Now, on the observe, I want to see what you saw. What pattern did you see as you're looking at your table? Okay, so what I want you to do is write down, or type in rather, what relationship did you see between max and min and then your equation. Okay, well, you notice every time you see a minimum, what's going on in your equation. Okay, every time you see maximum, what's going on in your equation. All right. Okay, so hopefully what you saw, you wrote down something that talked about the negative sign versus no negative sign. So we have, with our maximum, here's a negative x squared. Max. Positive, minimum. Positive, minimum. Negative, maximum. Negative, maximum. Positive, minimum. Okay? So, if x squared is negative, it has a max. If x squared is positive, it has a min. And that is going to be true every single time. And we'll make more of a conclusion later on. Okay? Now, we want to take a look at the x values of the vertex compared to vertex form. And then look at our y values. And can we make a connection to something that we learned earlier this year? All right, so go ahead and answer this question. Type in what you saw. What did you observe? So, hopefully we saw something like this. Look at our vertex, 0, 0. Do we have anything that's changing here? No. Okay, I'm going to skip 3, 0. I'm going to come down to negative 2, comma 1. Negative 2, comma 1. We have a plus 2. That looks kind of similar. We have a plus 1. I want to focus on this plus 1 for a second. So this plus 1 and 1. Minus 3, negative 3. Plus 1, 1. Plus 4, 4. Okay? So, we've made a connection to our y values, hopefully, at this point. And our y values of vertex are added or subtracted at the end. The x values of the vertex, do those right quick. So here we go. Minus 3, positive 3. Plus 2, positive 2, negative 2. Positive 1, negative 1. Negative 2, positive 2. Nothing, nothing. So the x values of the vertex are the opposite sign inside the parentheses. Now, if we think back to before fall break, this is exactly like our transformations. Here's our parent function, vertex is 0, 0. If we toss it in there, our graph's going to move 3 to the right. And sure enough, a vertex moves 3 to the right. Okay? If we put a plus 2, it should move 2 to the left. It goes to the minus 2. If we put plus 1, it's going to go up 1. All right? So our connection is these are function transformations. Okay? In fact, they are translations. So let's go ahead and summarize what we have seen so far. So a quadratic equation has a maximum when the x squared is negative. Quadratic equation has a minimum when the x squared is positive. And vertex form of a parabola is h, or vertex of a parabola is h comma k. Vertex form is y equals x minus h squared plus k. Now, you're going to have a few questions that are going to ask you to identify the vertex from vertex form, and then also use vertices to make vertex form. And then you'll have homework 5.